we want to do in this video is take these two graphs and try and find formulas for them. Now in both cases what we have here is something that looks like a polynomial. We see lots of terms. And in particular, what we can say in both cases is that what we appear to have is a third degree polynomial. So let's talk about why that's the case. Well, notice what's happening in both cases. What we have is we have two terms, 1, 2, 1, 2. And remember that a polynomial of degree n has at most n minus 1 terms. So if we have two terms, then a degree 3 polynomial makes sense. It also makes sense because both of these kind of look like x cubed. We go off to infinity in different directions as we move off the side of the graph. So let's handle this first one, and let's think about what this might look like. So if we say we've got a function here, f of x, then remember from the book, there's going to be some constant, and then we can talk about three terms that will be 0 when we put in the right numbers. So notice that we've got three places where the graph is equal to 0. So let's start with the right one. We're going to need a place that when we plug in 1, we get 0, so I'm going to write down x minus 1. Here I need something that when I plug in negative 1, I get 0, so I need an x plus 1. And just like the previous one, here I need an x plus 2. Now that figures out a lot of stuff, except for the fact that we don't know what the k is. And for that, it's often good to use the vertical intercept, which is negative 4. So note that when we plug in 0, we get out negative 4. So let's do the same thing here. Our output is negative 4. That's k times, now let's plug 0 into all this. Negative 1, positive 1, positive 2. And from that we get that negative 4 equals negative 2k. That means k equals 2. So here's our formula. F of x equals twice x minus 1, x plus 1, x plus 2. Do not worry about multiplying this out. Please, please, please. Alright, same idea down here. So let's talk about g of x. That's going to be a k. Let's see, I cross here and here. The first point's easy to work with. That is x minus 4. And then I write down x plus 1. And that's because when I stick in negative 1, this will go to 0. But notice something. I only crossed twice. This is a third degree polynomial. I need three x's multiplied together, so I need another term. Well, the idea here is that you can think of any situation where the graph bounces off the x-axis, that you have more than one term in the factorization. In fact, if we just pulled this graph down a little bit, it'd cross at two places, both really close to negative 1. So we're going to just say that when we write down the factorization, we're going to think of that x plus 1 as occurring twice. Or in other words, when you see a bounce like this off the x-axis, write down that number twice. Okay, so again, we need to figure out what the k is. So there we have the fact that we have an output of 12 when we plug in 0. So this is going to be k times negative 4 times positive 1 times positive 1. So 12 equals negative 4k. K equals negative 3. It is good to see the minus sign there, because remember, your traditional x cubed starts low and then goes high. This starts high and then goes low. So it looks like we flipped it over the x-axis, which is great because we got a minus sign there. So g of x is going to be negative 3 times x minus 4 times x plus 1 quantity squared. And that's the formula that corresponds to that polynomial.